Okay, thank you for this invitation. Very briefly, the outline of my presentation. A few words on my institute, INRAE, and my lab in Avignon. Then I want to show you how we can monitor crop using remote sensing data from plot to territory scale, using some method developed by my teams in INRAE, and then how we can also detect some farming practices with high spatial resolution, and how we can combine this remote sensing data in model to assess yield and water budget at different spatial scale. And finally, I will present you some study cases for integrated approaches for modeling and for sustainable development scenarios. A few words on INRAE. It's a National Research Institute for Agriculture, Food and the Environment, with 18 centres in France. And it's mainly to produce scientific knowledge to solve major challenges in the world concerning agriculture, food and the environment, which rank third in the world for agricultural science. And my lab in Avignon, in the southeastern France, it's a mixed research unit with academics from Avignon University and research from INRAE, with different skills in agronomy, ecology, soil science, hydrogeology, and modeling and remote sensing, mainly focus on water resource for Mediterranean agroecosystem, and we develop method to modify agricultural practice to obtain sustainable agriculture and to test different cultivar selection, phenotyping, and at different scale in the context of the climate change. As you know, the context of global change, we have seen this morning different slides on the same subject. We observe an increase of drought period. We observe also urban sprawl on agricultural lands, increase degrees of water resources, and more frequent events. As you can show on this, oops, excuse. I don't know where. Laser. Okay. This graph I have taken from the Indian Meteorological Department. We observe an increase in temperature and increase also of more frequent extreme events. And the main challenge is to have an integrated management of resources for both water, soil and biomass, and a sustainable development, taking into account the spatial and temporal variability of crops. And for that, remote sensing is a useful tool to characterize this spatial and temporal variability, because we can have different information, as we have shown with this morning with Gilles, according to the different spectral range. So, very quickly, Gilles has also shown a similar slide. We have different information according to spectral range. In the microwave range, we have information on soil moisture, soil roughness, and biomass, and we can have image even if we have cloudy days. But in the optical and infrared range, we have different information on vegetation structure and also optical properties of leaves. And often we use a different combination of this spectral band to define index, vegetation index. Most common is normalized vegetation index, NDVI, combining red and near-infrared bands. But also we can define more biophysical variables, such as LEI, F-cover, leaf area index. It's one side green leaf area per unit ground surfaces. And these indicators are more related to biological process, and we can integrate more this variable into model of functioning. So I will show you some example using this variable for crop monitoring. And as you know, we have more and more data, and recently with the Sentinel mission, Sentinel satellite, Sentinel-2 in the optical and Sentinel-2 in infrared and optical range, and Sentinel-1 in microwave, we can have image every 3 or 5 days with a pixel, a very fine resolution, 10 meters. So we can identify a lot of things, and you will see different examples using this satellite. For example, here, if you have an example of a rice crop in the southeastern France, where you can see the development, the phenological development of rice with this index, leaf area index, and from the sowing date, then the flooding, and the maturity, and then the harvest. If we want to follow this crop for the management, we can do ground measurement, ground observation, taking, for example, hemispherical photographs, and we have developed at INRAE software to process these images and to compute and to derive these indicators of the structure of vegetation. Leaf area index, it's free for the different teams, and it's easy to use and to characterize the crop development. But it's not easy to make ground measurement, and we can do everywhere. So we can use also Sentinel-2 data, image satellite, and we have more data. At farm scale, you can see the difference between the different fields. Here, at the farm scale, the flooding, and then when the crop develops and become more green, and just up to the harvest, you can follow the development of the crop using this data. And in the same way, we have developed at INRAE a model to compute the main variables from the satellite, leaf area index, F-cover, using a adaptive transfer model combined with a neural network, and which can be used for various satellites, and it's useful to have an indicator of the crop development. And so we can use this model to map this index at farm scale, and we can see variability due to the sowing date or due to the choice of the farmer, if there are different varieties of rice, for example. And then we can interpolate between each acquisition date, and we can have daily value. I have a video. I don't know if... Yes. So you can, for each day, we can follow the crop development at farm scale or at territory scale, and how the plant grows, and see the precocity or which variety is late, and it can help for the water management. And at the end, you have another graph showing different rice crop, different rice plot, and for different varieties, and you can show clearly variability between fields, but also we can clearly identify early and late variety and the phenological stage for each crop. But with the same satellite, we have also information on the spatial variability of some farming practices. On these small images, excuse me. You can see the flooding, you can see the soil just before the sowing date. We can identify very clearly the field where it's the harvest. We can also compare different years, and for the same field with the same variety, if we analyze the temporal profile of this vegetation index, we can clearly see here that you have a shift, and it's mainly due to different sowing dates. So we have information on the sowing date, we can have information of some practices, and also we can map the burn area. Some farms use fire at the end of harvest. If we combine different spectral bands, particularly in the middle infrared, here you have the difference between burn area and some film which were not burned. We clearly identify fire, and we can map these practices at regional scale and have information on different farming practices at regional scale. And another example is also the use of remote sensing for land use classification using different methods, and for example machine learning methods such as random forest. Yesterday we have seen different examples with Nagashima. It's the same approach, similar approach, using the combination of different spectral information of Sentinel-2 data here to map the interrow management of orchard. If you have from grass in the interrow, there are competition for the water between tree and grass, and so it's useful to map this interrow management for the water manager who use the different water at the territory scales. Another different method can be used based on the analysis of the temporal profile of the different crops, and we can use a phenological model to extract some key points, and instead of using all the data, we use only some specific point describing the temporal evolution to map, for example, very heterogeneous crop, and we can separate orchard and vineyard with high accuracy, as you can see. It's a PhD work, the last result here. Very quickly, I want to show you the complementary between microwave and optical spectral radar at plot scale. You can have information. Here you have an orchard and the soil moisture in summer with high evaporation, the soil moisture degrees. And if we have at plot scale information with radar data and also with optical and near infrared, you can see clearly heterogeneities at plot scale, which can be due to heterogeneities in soil, but also in tree density or in irrigation management. And you have different information in spectral range on the crop development, but also on the soil and the irrigation management. So if we combine this information, you can manage better this crop. And just to inform all these variables can be used in different modeling, such as crop model, for example. We can use forcing remote sensing data and into the model to analyze yield map, for example. And it's an example that is here for the rice. At regional scale, you have all the variability of production at regional level, but you can also use remote sensing to retrieve input parameters. And such approach was used in different projects in India, in Aisha and Aisha project. When we don't know soil properties or nitrogen dose, we can use remote sensing and compare simulation with satellite observation to retrieve the correct and the good parameters. And when the models are well calibrated, and we can then seems to simulate different climate change or land use change or water scenario with integrated modeling. So we have different layers of specialized information, climate, soil, land use, from remote sensing, and we can combine different models, irrigation model, crop model for production, but also hydrological model to analyze the impact of some practices on the ground table level, for example, and on the production. And such approach has been used on a small area where we have grassland irrigated by flooding, and we have analyzed different scenarios, combined different scenarios with climate change, with change in water right or land use change, and we can produce map for the present, for the prediction, for the piezometry level, and we can make differences between the future and the present. And then we can outline where there are some area and quantify the impact on the production, on the ground table, on the water reserve, and analyze the best way to improve and to choose some practices, sustainable practices. Just a very quick slide to present the STIX crop model. It's a crop model widely used by the scientific community, and there are every year English formation, and I think in India and Bangalore some people have learned this model. It's also for banana, for very exotic also crops, and is operational. There is operational application at front scale for grassland, but to predict production, but also different application for rice. If we move the sowing date, or if we change rice variety, we can quantify the impact on production according to the choice. So if you want to use this model, it's possible, and so it's open. So just to finish, it's very quickly, I want to show you that remote sensing at high spatial resolution, and particularly with a Sentinel mission, provide useful information for crop monitoring. There are now operational tools, the operational method. Some of them are developed at INRAE. They are open, and we can share with you these tools to characterize the plant development and help the crop management from farm to farm scale. Various methods can be used to assimilate in various models, and taking into account this spatial variability. Calibrated model can be used then to predict scenario, and it can help also to quantify the impact of the water resource. And also, I think it's always important to maintain ground measurement on long period to validate the different models. And for the future, I want to just outline that we have more and more information with satellite and with very high resolution. In the next year, we will have Neo-Pleiad, and for India, I think it can be interesting because you have very small plot, and future Krishna also data will be very useful to characterize agroecological transition with mixed crop, which are sometimes difficult to identify. So if we can collaborate with you with some tools that I have presented you, we can discuss tomorrow for future collaboration and for sharing this method which can be applied at different regions. Thank you for your attention.
Long live India and France friendship.